Okay, in the last video, we understand the intuition behind an insertion sort algorithm, right? And also we worked with a very simple example to clearly understand what is happening internally during the sorting process. Now, let us move on to the next step, that is writing a code, right? So this is very important step. So as important as intuition is, it is equally important to develop the ability to convert that intuition into an actual code. So at this stage, we had several choices, right? So we could have written the code in any major programming languages. So it could be C, or it could be C++, or it could be Java or JavaScript or Python, right? Or Ruby, you name it. There could be many programming languages are available. However, we decided not to choose any specific programming language here. Instead, we will go with, or we will write an algorithm using a pseudocode rather than using any programming language. Now the pseudo literally means it's false or not real. So pseudocode is not an actual programming language. It is structured way of writing an algorithm using a simple English statements. And also we are going to combine with programming style construct. I'm going to explain what are these are in a while. Now the main important question here is, why are we using the pseudocode rather than any programming language? So there are the two main reasons. So the first reason could be, our students come from the diverse programming backgrounds. So some students may comfortable in C, are very comfortable with C programming language. Some students may very comfortable with C++, or some may priorly know Python, right? And others may be web developers who are comfortable with the JavaScript. And some may know the Java programming language, and some may know some other programming language. So if we choose any specific, or if we choose one specific language, it may be disadvantageous to the students who are familiar with the other language. Now the second one, which is, every programming language has its own language specific details. For example, in C, we may need to deal with pointers, right? Either C or C++, right? So we have to deal with the pointers and the memory management. In Java or JavaScript, you may have to deal with classes, especially object-oriented programming concepts like classes, right? And someone who knows only C and may not familiar with classes and object-oriented programming. And someone who knows a C++ would like to understand the classes and inheritance, but that may not be true for everyone, right? Even though he is comfortable in C++, he may not comfortable in maybe other or not comfortable understanding of classes and objects, right? So these language specific details can make the code more cumbersome and distract us from our main goal, so which is understanding an algorithm. So our ultimate goal is to understand an algorithm. That is our ultimate goal. So the primary goal in studying data structures and algorithm is that once you understand the intuition behind an algorithm, right? So what insertion sort is, once you truly understand what insertion sort is, you should be able to implement in any programming language you are comfortable with. So that's why we want to use a language independent way of writing code. Even though the pseudocode is a language independent, but we are going to use some basic construct which most of the programming languages are using it. And this pseudocode is a language independent. So what are the some basic constructs which are used in every programming language? So these are the constructs. The constructs are variables, right? If else statements, and for loop, and while loop, right? And function. So these are the basic constructs which we are going to use it in every programming language. So these constructors are common ideas across almost all programming language. So in our pseudocode, we will use only these simple and universal construct. We will also avoid advanced and the language specific features, right? I hope you understand, right? So why we choose a pseudocode rather than programming language? Maybe let me give you one more thing. Today you might be writing a code in C. Tomorrow you might switch to Python. Later you might work with a JavaScript or Java. However, your understanding of data structures and algorithms remains same, right? So your data structures and algorithms remains the same. So I would say that algorithms are universal, but the programming language is just a tool. Programming languages are just a tool of it. So that is why we will use only a very simple and common programming construct to explain the code, and our focus is mainly on the algorithm, not on the syntax of a particular language. So now to present the pseudocode in a clean and structured way, I went through a lot of textbooks, several textbooks and blogs to explore the best way to explain an algorithm to all of my students. So the best reference I found was the book called Introduction to Algorithms. So this is one of the best book, extremely popular both undergraduate and the graduate level, and it is written by 4 authors. The first author was Corman, Insertion, and Rivest and Steen, right? So these are the 4 authors who have written this book. Because of the author's last name, the book is commonly referred as CLRS. So commonly referred as CLRS book. In my opinion, it is one of the best book I have ever written on algorithm. And it remains one of the finest resources I have ever read for understanding an algorithm deeply and rigorously. So after reviewing several sources, we decided to stick to the pseudocode notation used in the Introduction to Algorithms book, so commonly known as the CLRS book. So the reason is very simple. The pseudocode in CLRS is very rigorous, and also it is precise, well structured and carefully written and thoughtfully designed. So there is a lot of mathematical and a logical rigor in the way the algorithms are present in this particular book. So because of this clarity and consistency, I decided to adopt the same code or the same pseudocode style throughout this course. And another advantage is that it makes revision easier for you, right? Let me show you. For example, if you ever want to quickly look at the insertion sort pseudocode, right? So you can simply go to the Google images and search insertion sort CLRS, right? Or CLRS by insertion sort algorithm. So you will immediately find a clean and well formatted version of an algorithm, right? So when you look at the pseudocode, here there are 2 other extra columns, right? So this is my entire pseudocode of that algorithm, right? Now other columns are cost and times. For now you can ignore those. We will discuss what the time complexity and the cost analysis in detail little later. At this stage, just focus is purely on understanding of that algorithm itself. And the important part is the core code snippet. So it is more concise, clean and beautifully structured. So that is the style we will follow throughout the course, right? So throughout the course, we will extensively use the pseudocode inspired by the CLRS notation. So having said that, now let us move directly to the pseudocode for insertion sort algorithm. Now I have taken the exact pseudocode we saw in the image, right? So we saw in the image from the Introduction to Algorithm, and I have written it down so that we can understand step by step. Now let us carefully look at what is happening here, right? So we have a function. So at line number 1, so we have a function called insertion sort, right? And this function takes array A as an input. So this is the first thing you should notice here. Now before dive deep into the logic, let me explain some of the formatting and the notation used in the pseudocode. So it may look slightly different from what you have seen in C or C++ or Java. So that is the reason. First, let me explain the formatting and the notation used in this particular pseudocode. Now if you look at the code, first thing you should notice here is, here I did not use the curly braces, right? So typically for the function, we will start with this open curly braces, and this entire code, or the code what you have written inside the function, after that we will end with the closed curly braces. But in this particular case, I did not use this notation, or I did not use this syntax, right? So CLRS style pseudocode does not use the curly braces. So instead it uses the concept called an indentation, right? So let me explain what is the indentation means. So indentation simply means any line that is indented, that means shifted few spaces to the right. So are you able to see there is a space between here to here, right? Here to here, right? So any line that is indented, that means we shifted few spaces to the right, belongs to the block above it. So if you see the for loop, everything that is indented under it is part of the loop. So this entire code is part of the for loop. So this entire code is part of the for loop. So even this style is very similar to a Python programming language, and this language also uses an indentation instead of curly braces. So this approach makes the code more clean, readable, and easy to follow, right? That's why we are using the notation of CLRS to understand any algorithm. Now observe carefully here, we have a for loop, right? Inside the for loop there is one more loop called a while. The lines that are further indented belong to the while loop, right? So these two lines are belong to this while loop. So I further indented, so these lines are belong to the while loop. So the structure is, so in this entire code snippet, or this entire pseudocode, the structure is as follows. The while loop is present inside the for loop. Certain lines are inside the while loop. Other lines are inside the for loop but outside of the while loop. So here the indentation clearly tells us which line belongs to which block. Now let us walk through the same example we used earlier so that you can clearly connect the intuitive explanation with the pseudocode. Now first we'll understand the outer loop, right? So we are going to start with the line number 1, the outer for loop. So the pseudocode says that for j is equal to 2 to a dot length. So here a dot length simply means length of an array, or I would say the total number of elements present in an array. So in our example, how many number of elements are present in my array? Total 8 number of elements. So my a dot length is equal to 8 here. That means the value of j runs from 2 to 8 to 3 and so on 8. Now the next question here is, why does j start at 2? Why the value j doesn't start with a number 1? Because the first element, that is index 1 in CLRS notation. By the way, I'm using the index start with the number 1 as per the CLRS. But if you are following the C notation or C++, the index number start with the number 0. So index will start with the number 0. So here I have only one element. This is trivially sorted. So we start from the second element. That is the reason we are starting it from the second element. Now you have to start from the second element and try to insert it into the already sorted portion. This matches exactly what we did in the intuition, right? So now let's take the value of j. So my current value of j is equal to 2, right? So in this particular iteration, let us walk through the each and every step or the every line of code what I have written in this pseudocode, right? Now at this particular line, what I did, I assign a key, right? assign a key. So what is the value of j? My value of j is equal to 2, and a of j is what? A of j is equal to the element present at the second index is 5. My a of j value is 5. Now I'm assigning a of j to the variable which is equal to key. So that is what I explained in insertion sort intuition. That is what we did, right? Now the next step is initializing the value of I here. So what is the value of I here? I is equal to j minus 1, right? So I is equal to, what is the current value of j? Current value of j is 2. 2 minus 1 is 1. Now the value of I is equal to 1. Now I will go to the next step, the next statement. This is my while loop. I entered into the while loop. So here I am trying to check the two important conditions. So the first condition is I is greater than 0 and a of I is greater than key. Now let me go and check the first condition. The current value of I is 1. 1 is greater than 0. Yes, this condition is true. What about a of I? What is the value present at index 1? Which is 6. 6 is greater than, what is the value of key? 5. Yes, this condition is also true. If both the conditions are true, I need to execute this particular block, the statement which are present as part of the while loop. That's why I gave the indentation, right? So these two statements are belong to this particular while loop. Now I will enter into the while loop. At the first statement I have is a of I. This value should get assigned it to a of I plus 1. So what is the value of a of I? What is the value here? A of I is what? 6, right? Let me write it down here. I'm assigning the value 6 to which position? A of I plus 1. 1 plus 1, that is equal to 2. So at position 2, I am modifying the value here, right? So here I did not delete the first element yet. We simply copied this element and move it to the right. So at this position, I change the value from 5 to 6. That is what I did here. Now let's move on to the next statement. I is equal to I minus 1. Now the value of I becomes 0. Right? Now again I will go and check the condition here. So 0 greater than 0, the condition is false. Now I will come out of the loop and execute the statement which is outside of my while loop, but this statement is part of the for loop, right? So you need to be you need to check the statements properly. What are the statements are part of the for loop, or what are the statements are part of the while loop? And this statement is belong to the for loop. So what this statement says, key should get assigned it to this position. So you need to update the value in this particular position. So the current value of I is equal to 0. 0 plus 1 is 1. At a of 1, I need to keep the value of what? Key. Key value is 5. That means I'm changing this value 6 to 5. I hope you clear with this code, right? The pseudocode what I have written here. So at the end of this first iteration, at the value of j is equal to 2, at the end of this first iteration, first two elements are now sorted. So 5, 6, right? So what happens next? Again, I will go and pick the next value of j. What is the next value of j? Which is equal to 3. Now, I would strongly recommend you that writing this down in your notebook, and you should repeat the same process on the paper. So at j is equal to 2, at j is equal to 3, at j is equal to 4, at j is equal to 5, and so on. So when you do it manually, you will clearly see how the outer loop picks the next element and how the inner loop shift the larger elements to the right hand side. And also the key is getting placed at its correct position. So you are going to observe the three things. Now, how the outer loop, let me write it down here, how the outer loop picks the next element, and how the inner loop inner loop shifts the larger element, shifts larger elements to the right hand side, to the right. And the third important thing you should notice here is how the key gets placed in its correct position, in its correct position. So these are the three things you should notice while executing the entire algorithm by keeping the value of j is equal to 3, 4 and 5 and so on. Now one more important thing I want to mention here is at any moment when the value of j is equal to k, let's say the value of j is equal to k, right, the sub array from a1 to k minus 1, so this is from 1 to k minus 1, so this is my sub array. So this sub array is already sorted, and what I'm gonna do, take the value a of k as the key, compare it with the elements to the left, and you need to shift the larger elements to the right. So insert this element, so this particular element at its correct place. So for example, if the value of j is equal to 6, from a1 to 5, this sub array is already sorted. So we take a of 6 as the key, so this element as the key, and compare this element with a of 5, and compare this element with a of 4 and a of 3 and so on. And you need to shift the elements that are greater than the key and insert the key at its correct location. So this is exactly the intuition we described earlier, right? Once you understand this intuition, this code is like a cakewalk, nothing fancy, nothing complicated here. I hope everybody clear about the entire pseudocode of an insertion sort algorithm.